Here is one where we go over the supply chain and risks of large language models. We can pretty much read the abstract on this, but when we open up the PDF, which I'm going to do, I'm going to point to some specifics here. This study goes over the fact that most other scientific studies, when they look at the security of LLMs, judge the security of LLMs by things like prompt injection, or distillation techniques, or training data leakage, or backdoors inside of the systems that the system prompts and things like that. However, what people forget is that these systems have to start somewhere. If you're going to create a system like this, if you're going to create an LLM, it's got to run somewhere. There's some code that has to start somewhere. There's a data set that has to start somewhere. All of these things require some amount of technical path that exists outside of the LLM. And guess what that path is? Code. And what do I constantly complain about with regards to the tech industry when it comes to coding? People these days have a massive overdependency on libraries, frameworks, abstractions, obfuscations. And guess what? When it comes to creating these LLMs, it's no different. And so now if we go into it, what they've done, they looked at 3,859 LLM applications, including ones that are run locally. So things like you go to the App Store, you download an app, and it's LLM enabled, and it's just an LLM that runs on your phone if it can handle that, just as an example. 109,211 models, 2,474 data sets, and 8,862 libraries, along with their dependency relationships. To assess the security posture of the LLM ecosystem, we extract a total of 1,555 risk-related issues, 50 for applications, 325 for models, 18 for data sets, and 1,229 for libraries, sourced from various public vulnerability databases and repositories. So you can kind of see where I'm going with this. What they took a look at is, well, how does one go ahead and create an LLM application to begin with? Whether you're OpenAI, Gemini, Mistral, Midjourney, specialized applications that you sell as like one-offs, RAGs, MCPs, the data sets involved in them, etc., etc. And of course, you're going to need to do things like pull in Python as an example. So they discovered that the dependency of all of these LLM systems numbers at the very least, hundreds of different types of dependencies, which then branch off to tens to hundreds of different web dependencies out of that. So data sets would be one dependency, which has then a further dependency to a bunch of other stuff. And then they have programming dependencies, which then have other dependencies to like third-party systems, especially with Python, etc., etc. So in the conclusions here, they go over, well, let me go back. So there's a dependency risk, number of vulnerable dependencies per app. And essentially what they did was they took the total number of apps that were running on some kind of LLM-based like underpinning. And the more apps that they looked at, the more the vulnerable dependency per app number went up. And then it kind of flatlined because there was a point where it's like, well, geez, some of these apps are dependent on like so many similar things as many other apps that you can essentially count the number of dependencies as the same as every other app we've seen before. So the entire concept here is that Data sets are vulnerable, databases are vulnerable, the code that operates this stuff is vulnerable. You can see some of the code libraries, the packages, PyArrow, Torch, LangChain. You have Pillow up here, you have Paddle. All of these things have, look at the number of critical vulnerabilities here, 36 at the top. And the code that operates underneath that makes the LLM capable of running to begin with has these third-party dependencies, which are in and of themselves capable of being exposed because they have vulnerabilities in them. Now what you can do is you can consider how these LLMs are being used to produce even more apps like this. So the more that you generate all of these dependencies, the more that you use AI to vibe code more apps, more packages, more instances of LLMs and so on, the more you stop looking at what your dependency tree is as you generate these things, which means that the number of vulnerabilities will at the very least not really decrease, if not go higher. You can look at the dependency depth in terms of number of apps. You can see that there are 1,799 apps that have you can see it's here. Yeah, 1,799 apps that have a dependency depth of 8. And a dependency depth of 8 is actually really, really deep. The number of libraries, about the same thing. Right? So all of these are attack vectors that exist simply by the nature of getting these things to run in the first place. So unfortunately, what this means is that they come built in. These systems come built in with a bunch of vulnerabilities across a variety of different, moving pieces that make the LLMs function. And we haven't even begun to consider what it might look like if somebody took a dependency like Pillow from the Python toolchain and started to use it to manipulate the creation of newer models. And what would that even look like? We don't know. As far as we know, it hasn't happened yet. And when it does happen, what's going to happen to the fundamental underpinnings of all these LLM systems? And the more that this kind of stuff goes swept under the rug or ignored, the more that we're just going to dog food our own vulnerabilities here. And we're just going to generate more ultimately, because we know that LLMs like to generate insecure code at a rate of sometimes like 90%. That's been scientifically proven. So this is a very serious problem. We're putting a lot of trust on some very shaky foundations. The good news, we know where the foundation is shaky. We could go clean it. But are we going to do that? That's the question, right?